Imagine walking through the streets of a massive metropolitan center in the middle of the 19th century. On the surface, you see the height of human achievement, with grand stone buildings, bustling markets, and the latest fashions. But as you step closer to the curb, the reality of the era hits you with a physical force. It is the smell. It is a thick, heavy, and inescapable stench that clings to your clothes and defines every waking moment of city life. This was the era of the great urban bottleneck, where humanity had figured out how to build upward and how to gather by the millions, but had completely forgotten how to deal with the most basic byproduct of living. Before we could truly enter the modern age, we had to solve the problem of our own waste, and the solution would become one of the greatest and most invisible engineering feats in history. In those days, cities were essentially giant sponges soaking up filth. Most people lived above or right next to shallow pits called cesspools. These were often nothing more than holes in the ground, tucked away in a basement or a small backyard. When they filled up, they stayed full until someone was paid to haul the contents away by hand. In the poorest neighborhoods, the waste simply overflowed, trickling into the streets and seeping into the foundations of the buildings. The rivers that ran through these cities were not the scenic landmarks we know today. They were slow-moving, black ribbons of sludge. People used the same water for washing their clothes, cooking their food, and dumping their buckets. It was a closed loop of contamination that turned every summer into a season of fear. The hard constraint was simple and terrifying. A city could only grow so large before it started to kill its inhabitants faster than they could be replaced. Disease was a constant shadow, and while people had many theories about why it was happening, they lacked the infrastructure to stop it. Some thought the bad air itself carried the sickness, a theory that actually helped push for change because the air was undeniably foul. The bottleneck was not a lack of medicine or a lack of money, but a lack of a system. There was no coordinated way to move liquid waste away from the people who produced it. Without a way to flush the city clean, the Industrial Revolution was threatening to choke on its own success. The turning point came during a particularly brutal summer in the late 1850s. The heat was so intense that the main river in one of the world's largest cities began to ferment. The stench became so powerful that it actually reached the halls of government. The people in charge tried to hang curtains soaked in chemicals to mask the smell, but it was useless. They were trapped in their own offices by the very problem they had ignored for decades. This moment of crisis broke the political gridlock. It was finally realized that the city could not survive as a collection of thousands of individual pits and disconnected pipes. It needed a single, unified nervous system for waste. The breakthrough was not just a new kind of pipe, but a master plan for the entire landscape. Engineers proposed a massive network of underground tunnels that would use the natural slope of the land to carry waste away from the center of the city. These were not just small drains. They were colossal brick-lined cathedrals buried beneath the streets, built with enough precision to ensure that gravity did most of the work. They had to invent new types of cement that could harden underwater and withstand the corrosive environment of a sewer. They had to dig up the very foundations of ancient neighborhoods, laying miles and miles of brickwork by hand in the dark and damp earth. As this system began to take shape, it changed the way people thought about the city itself. It was the first time a major government had taken responsibility for the invisible health of every citizen, from the wealthiest merchant to the poorest laborer. The scale of the project was mind-boggling for the time. It involved millions of tons of earth and laying hundreds of millions of bricks. To make it work, the engineers had to create massive pumping stations that looked like palaces, housing steam engines the size of houses just to lift the waste and keep it moving toward the sea. This was the beginning of the quiet revolution. Once the main arteries were in place, the system began to scale. Smaller pipes from individual homes were connected to the larger tunnels, creating a web that reached into every corner of the urban environment. This standardization was key. It meant that new buildings could be designed with indoor plumbing as a requirement rather than a luxury. It created a massive market for manufacturers of pipes, valves, and porcelain fixtures. The economics of the city shifted because land that was once considered a toxic wasteland suddenly became prime real estate once the smell and the threat of disease were managed. The ripple effects were profound. Life expectancy began to climb as the waterborne diseases that had haunted the streets for centuries started to vanish. The city became a place where people could live in high density without it being a death sentence. This allowed for more workers, more commerce, and more innovation. It also changed the physical look of the world above ground. In many places, new roads and embankments were built right on top of the new sewer lines, creating grand boulevards where there used to be muddy banks and stagnant pools. The city literally rebuilt itself on top of its new waste system. However, these systems were expensive and difficult to maintain. The cities that could afford to build them gained a massive competitive advantage. They became the centers of global trade and power because they were the only places that could support millions of people in relatively healthy conditions. The cities that lagged behind remained trapped in the old cycles of plague and stagnation. This created a new kind of divide in the world, one defined by the quality of the invisible infrastructure beneath the feet of the citizens. Even though we rarely think about them today, these 19th century systems still matter. In many of the world's oldest and largest cities, the original brick tunnels built over 150 years ago are still in use. They are the silent foundations of modern life. When we turn on a tap or flush a toilet, we are interacting with a massive, complex machine that spans an entire continent. This engineering marvel is the reason we can have skyscrapers, stadiums, and crowded subway stations. It is the ultimate quiet component that makes our modern way of life possible. We have moved from a world where waste was a constant, visible threat to a world where it is almost entirely forgotten, tucked away behind walls and under pavements. Today, as our cities face new challenges like rising sea levels and rapid population growth, the lessons from that era of engineering are more relevant than ever. We are learning that infrastructure is not just something you build once and forget. It is a living system that requires constant care and visionary planning. The engineers of the past taught us that to move forward, we sometimes have to look down and fix the problems we would rather ignore. Their success gave us the luxury of cleanliness and the ability to imagine even bigger things. While we were learning how to keep our cities clean and healthy, we were also figuring out how to connect them to one another in ways that were just as revolutionary. The same spirit of engineering and standardization that built the sewers was also being applied to the way we moved across the landscape. To truly understand how the world became a single, interconnected system, we have to look at how we laid down the lines that defined our movement. That story takes us away from the tunnels beneath the streets and out into the open countryside. It is a story of how a different kind of track changed the way we perceive distance and time. In the next episode, we will take a quick step sideways in our timeline to look at the railway revolution and the birth of the standard gauge. This is the missing context that explains how the world finally synchronized its heartbeat and began to move as one. If you found this dive into the hidden history of our cities interesting, please subscribe and join us as we continue to explore the technical foundations of our world.